Hi there, and welcome to Mr. Morgan's Math Help for Algebra 1. All right, we are still in Unit 1 on one variable statistics, looking at Lesson 4 today called the shape of distributions. The shape of distributions. So as we get started today, just a few things to look at. First of all, our learning goals says to go ahead, and today we're going to says, let's explore data and describe the distributions. So we're going to start talking about how the distributions look, what their shape might be. Do we see things that look like this? Do we see things that look like this? Do we have data that looks like that? Or is it just always the same? Who knows? We're going to talk about the distributions and describe them different ways. Our learning targets today, I can describe the shape of a distribution using the terms symmetric, skewed, uniform, bimodal, and bell-shaped. We're going to talk about all of those on the next page. Symmetric, skewed, uniform, bimodal, and bell-shaped. So if you're taking notes, we're going to write down what those words actually mean. And finally, I can use a graphical representation of data to suggest a situation that produced the data pictured. Meaning, let's say I had some kind of chart, right? And a little histogram like this, and maybe I can figure out what kind of situation was used to make that sort of graph, that sort of chart, whatever it might be. All right, that's the idea today. So let's take a look at today's lesson. We begin, first of all, kind of which questions here. Which one doesn't belong? Distribution shape. Okay, really looking here at what's on this side for now. And we can see, first of all, with the first one, we have this nice curve going on here. And we can see that it curves up and goes up and then curves back down. All right. The second one, we see a curve that starts up pretty high here and kind of dips in the middle and comes up. With C, we go straight all the way across, all the same values there. And then with D, there's not much happening, and then it whoop, goes up sharply and then drops off pretty quick. So they each have their own kind of shape, so to speak, don't they? Right, of what they look like and what's going on there. So we could describe them different ways. Now, the way we describe these things is important for how we describe the distribution of the shape, what it looks like. One of the first things to look at is this word symmetric. Now, most of these here are going to be symmetric. You can be symmetric while being skewed, and sometimes you can be skewed. Symmetric while you're being a uniform or bimodal or bell-shaped. Those things can happen while being symmetric. Symmetric means that the mean is equal to the median. Okay, we've looked before, if you recall the homework the other day, where we had a dot plot where we had 5, 6, let's just do 5, 6, and 7. We'll do 5, 6, and 7. 5, 6, 7. If I have a dot plot where I have 1, 2, and then 1, 2, 3, 4, and then 1, 2, and I said, okay, well, what's the median going to be? Well, the median is the middle number. I have 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So the median is going to be here, right? If I cut them in half, I have 4 there and 4 there. So my median is going to be 6. Well, my mean in this case here would be to add those up, right? So this is going to be 24 plus 10 plus 14. So I'm going to be sitting here at 48, and I'll divide that by 8, and we end up with 6. So when my mean and median are equal, that means that I'm going to have a symmetrical shape. So even though this looks symmetrical, which it actually is, right? That's symmetrical. It really is. I could also have the same thing kind of reversed, right? I could do this. Let's get rid of that guy real quick. I could also say that I had a dot plot that looked something like this. Let's say I had 1, 2, 3, 1, 1, 2, 3. Well, now if I asked you where is your median, you'd say, well, there's 6, 7, so the median is going to be right here. And if I asked you what the mean is going to be, it's also going to be right here. So even though our chart might look this way, kind of rounded like B, it's still symmetrical. So symmetrical means that the mean and the median are equal to each other. That's the key thing there, that they're equal. That makes something symmetrical. So when I look over here at the shapes here, I would say that A looks very symmetrical because the mean is probably going to be somewhere in the middle, as is the median. B definitely looks symmetrical the way it goes there. C is going to be symmetrical too, because the middle is going to be somewhere here, and so the middle is going to be right at about the middle and the middle. But D does not look symmetrical because my median and mean are going to be somewhere over here, but because my median's over here and I have these numbers over here, My mean might be more like over here. Hard to say. So that's what symmetrical is about. The next term here for us to look at is the word skewed. So skewed means that one side of the distribution has more values than the other. So more values on one side than the other side. So an example of a skewed data point would be this guy right here, where we have more on this side than we do over here. That is definitely going to be a skewed. Okay? The next one is uniform. Uniform means it's evenly distributed data. Well, which one looks the more evenly distributed? Probably go right there, right? Everything has the same value on that side. Bimodal means there are two very common data values. Bi, like a bicycle, right, for two. So the one that has two common, we can kind of say this one has a cluster there and a cluster there. So we would say that's a bimodal example right there. And finally, our last one is a bell-shaped. It takes the form of a bell with most data clustered in the center. And so this is going to be our bell shape up here. So when we're looking at all our options here, what we have is we have a bell shaped here. We have a bimodal here. We have a uniform here. And we have a skewed one here. And of all those guys there, we have symmetrical, 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 and not symmetrical. Okay, so that's kind of the basic parts of today's lesson and what we're really talking about there, the shape of distributions and what those look like. Okay, so the activity today says to do what? It says take turns with your partner matching two different data displays that represent the distribution of the same data set or set of data. So your teacher's going to give you some cards, right? They're going to give you some cards, and one card is going to have, some kind of data on it, whatever that might be. And then they're going to have something else that's going to try to match that. Which one kind of goes with that display? So another card here to try to match what goes with it. Okay, so your job is to find, for each set that you find, so find a set and explain how you know it's a match is the goal there. And then listen to your partner and then see what you notice here. So I'm going to turn the page here, and what I did is I just went ahead and took 4 of the cards and chopped them up and mixed them up here. So let's take a look at the first data set. Let's make this one here. We'll just make this the yellow one here. So this one, we start off, we have a nice bell-shaped curve, right? We can see we're going to go up, bell-shaped, and come down. So we have a nice bell-shaped curve going from like about 1 over here. That's my number. I'm at 1 and I have 11, and that's my shape. So looking over here on this side, which one of these matches that? Well, I want a bell shape. Well, this is definitely a bell shape, but I notice that it goes from -19 to -7. So those numbers don't quite match. This one's not a bell, not a bell. Here's a bell, and I can see it goes from 1 to somewhere around 11, 12 in that range there, and it is a bell-shaped curve. So I would say that this one here is going to match this one right there because they have the same curve and also the same numbers. Okay, let's take a look at the next one. So here we also have a bell-shaped curve, right? But notice the numbers are now a -18 and -11. We're dealing with negative numbers. So the best option is going to be what? Probably this one with a bell-shaped curve dealing with the negative numbers. Okay, let's look at another one. Here, we can see we have what we would call what? Remember what this is called? Bimodal, right? That's right. This is going to be bell-shaped. This is bell-shaped. And this one here, bimodal. Why is it bimodal? Well, there's 2 like data points that seem to be equally high. 2, bi for 2. So when I look at the bimodal options left for me, I can see this one has 2 data points that look to be like what we have here, right? That curve down, and so that histogram is going to match that one there. Leaving us with just one more final option. Let's go with a pink, all right? Where we can see here the data is straight across like that, okay? And then we look over here, we're straight across like that. I know there's a little drop off right there, but I'm not quite sure why that worked out the way it did between -9 and 7. Oh, it's because just the way the numbers worked here, right? Here you're going -9 and -8, -19, 18. Well, there's 4 in each little group there. There's 4 there, 4 there, 4 there, 4 there. This one only has 2 in its group. And see how that works out there? That's why that looks a little different. But that one is going to be the matching one. And we call this one because it's all about the same uniform. Now, in all these data here, we got one thing we want to think about, is it symmetrical? Now, symmetrical, we said, means it has about the same mean and the same median. So the same middle point or the same average. And so all these ones here are, yes, they're all pretty symmetrical the way they're working out there. So nothing is asymmetrical. Again, back to our definitions. Symmetrical means the mean is equal to the median. So we would say, yep, that's symmetrical. The only one that wasn't last time was this one that was skewed, if you recall that one there. So we're going back over here. Nothing is really skewed. It's all pretty even all the way across. So that's our matching our shapes there. Now, the next part of today's lesson really then, besides being able to describe them and match them up there, is to figure out, well, where did the distribution come from? Meaning, what kind of question was asked that led to the data points that you see? What kind of question are you asking to get the graph together? So which situation produced the data distribution? So I went back here and we have the same ones with the same kind of skewed data points here, right? Or not skewed. We had the bell-shaped curve there, right? No problem. We had the bell-shaped curve here. Here we had the bimodal again. And here we have oh goodness, what's our word there? The uniform, sorry. Mine stopped working for just a second. The uniform data there. So let's take a look at our options for what we have to work with. A says, how many feet below the surface were each of the core samples taken? Okay, so we're talking about digging down below the surface and looking at our data points for which one could do that. Do you think you did samples at the 1, 2, 1, 2, 2 at 3, 4? It's a question of, I don't know if that's going to be how you're digging for. If you're trying to take samples of something, you probably want to be pretty consistent whenever you're doing samples and measuring something. So because I know this sort of event, you want to be consistent to do it right, you want to be pretty even and also going to be pretty, what we would call, uniform. So I'd probably say that A goes with this one right here because it's a very consistent. They're taking out 2 samples at -19, 2 at -18, 2 at -17, 2 at -16. Very scientific, very precise. So that makes the most sense for this situation, probably produce that data right there. Let's look at B. How many points did Kieran score in each of his 22 games this season? Okay, so someone's scoring points in a game, okay, 22 games. So right away we can look at this one here and say, well, these are negative. You're probably not scoring negative points, so that's out of the question, right? Here, maybe it's 1, but this seems kind of odd to have a bunch of 1 points and 8 points. I don't know a lot of games where you score 1s and 8s. Doesn't really kind of work for me, but maybe that's a possibility. Hard to say. Hard to say. Get rid of that guy there. All right. So then let's look over here. If I'm thinking like perhaps maybe basketball, maybe free throw, 2 points, 3 points, we can see there's definitely like an increase there. Question me, how many dots are there going to be? You want to find 22. That's a good question, what that's going to look like. But I would probably be safe to bet that most likely probably this one here goes with that one. It looks like the most points because I can't imagine that he just scored like a bunch of games with only 1 point and then a bunch with 8. That doesn't seem like a score. But again, just guessing them out here. For C, on a scale of 1 to 8, how was the service at the restaurant? Okay, well notice I have a scale of 1 to 8, which means my data points are only going to be 1 through 8. And right away I remember, oh yeah, this one went from 1 to 8. So that makes the most sense that this one's going to be from that situation there. Which then leaves me with one final question, right? What were the typical low temperatures in a Siberian town during January? Well, either way, it's going to be cold. And because it's going to be cold, we're looking for negative temperatures. and that leads me over here to where these negative numbers are going to be at. That one makes the most sense for D. Oops, sorry, D. That's terrible. I'm really good writing my pen, aren't I? Sorry about that. D. Okay, so basically the whole point of this second part of the lesson is, can you look at a situation and figure out what situation made the data over there? That's what we're trying to talk about. And that really is what today's lesson is all about, describing them and then looking to see, can you figure out how it got there? All right, so to wrap it up here, we can describe the shape of distributions as symmetric, skewed, bell-shaped, bimodal, or uniform. Here is a dot plot, histogram, and box plot representing the distribution of the same data set. This data set has a symmetric distribution. So here's our dot plot, here's our box plot, and here's our histogram. Same information. In a symmetric distribution, the mean is equal to the median, and there is a vertical line of symmetry in the center of the data display. Okay, and that's what we talked about before. With that information, we know we can have something like a bell-shaped distribution, which this is very much a bell-shaped distribution there, and that's one thing to talk about. We also can look at dot plots, right, and we can have things that show a skewed distribution. And a skewed distribution means that one side has more values farther from the bulk of the data than the other side. So this is an example of a skewed distribution here. Okay, this is skewed. And then we can also have ones that have very consistent distribution, or what we call a uniform distribution here. The uniform distribution, the mean is equal to median, since a uniform distribution is also symmetric distribution. So it looks very much like a rectangle, all the same. That's a uniform distribution there. Okay, and finally we can also have the bimodal distribution, where there's two very common data values, right? And so with that, you're often going to get symmetric ones as well, but you're not always, but sometimes you're going to get those. So bimodal distributions are not always symmetric, so be careful there. So sometimes they're not, but they tend to be. But you end up have these kind of like two little clusters of things happening with bimodal ones. All right. All right, so this is your cool down from today's lesson, that if you're in class, you can kind of pause here and work on this in class and see if you kind of get the hang of it before you take off, and really just kind of reviewing the same things we talked about today in our lesson. We're going to pause here and give you a chance now to work on your homework assignment, whatever that might be. Hopefully you take a time to do that, because it's important that you do it on your own to make sure you're getting the hang of it before you come back here and check the solutions out. So here we go. Make sure you pause and then come on back. All right. Practice number 1. Which of the dot plots shows a symmetric distribution? Now, symmetric, we said, means that it has a mean and a median that are about the same, right? Very much the same. Okay, so when we look at a data like A, we can see this one's a little interesting because it goes up and then it gets big and drops off. This one's definitely going to be a little bit skewed, and usually with skewed we don't have symmetry. With B, we can see we have a little, then it gets big in the middle and back down to little. We have that bell-shaped curve. Very likely this one is a strong possibility. Okay? For this one, I have some funny clusters. I have a chunk down here, I got some in the middle, I got nothing over there, then I have some over here, which means I'm probably going to have a median somewhere over here. Oops. I'm a median over here, but maybe a mean that drops in over here, not quite the same. So it's a little imbalanced for me. There's not a lot of symmetry there. So probably not going to have symmetric distribution. I would say no. It doesn't look balanced. And this one for D, we can see it's almost bimodal, right? Almost. And again, bimodal doesn't always have symmetry. It's kind of bimodal because you have a kind of a little cluster there, but this cluster is really big. We also have a lot over there compared to here. So we're a little bit off for the bimodal. So the best one, symmetry, is going to be B. That'd be the one I would choose. Number 2. Which of the dot plots showed a skewed distribution? So meaning it's not going to be pretty consistent. It's going to be all over the place there. So skewed, here we have this bimodal there, kind of an inverted bell shape. That does look pretty consistent, so no, not that one. This one, while it looks a little bimodal, we go up and down and up and down. It's pretty much the same. So that is, while it's bimodal, it's not fully skewed though. Okay, it's not having one thing on one. Remember, skewed is going to be something on one side but not the other. And this has it equally balanced. So no there. This is the bell. So nope. And this one we have a whole bunch over here, and then we get nothing. So we have it's skewed this direction. So that skewing to the left means that's going to be our best answer. Number 3, create a dot plot showing a uniform distribution. So uniform means that it's going to be pretty consistent, right? So I could have 2, 3, and 4. 1, 2, 1, 2, 1, 2. Nothing fancy. That is uniform. It's a dot plot. Check. And don't have to overly complicate things. I can make it bigger, but I didn't feel like it. All right, number 4. The data represent the number of ounces of water that 25 students drank before donating blood. So here's all our numbers here. It wants you to create a dot plot and then a box plot for the data. Okay, well, let's do that. One thing I notice here is that everything seems to be counting by 8s. 8, 16, 32, 64, 80, and 88. So for my dot plot, I'm going to count out by 8s first of all. So I'm going to go 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, 88. Sorry, ran out of room there. Didn't plan very well, did I? All right, so for my 8s, I have 3 8s. So 1, 2, 3. 16, I have 3 of those. So 1, 2, 3. 32s, I have 1, 2, 3, 4, 5, 6 of those. 1, 2, 3, 4, 5, 6. 64, I have 1, 2, 3, 4, 5, 6, 7 of those. Wow. 1, 2, 3, 4, 5, 6, 7. I have 80, I have 1, 2, 3, 4 of those. 1, 2, 3, 4. 88 is 3. 1, 2, 3. So there's my dot plot. To make my box plot, that means I want to find the 5 points, right? My 5 points mean I need to find the minimum, quartile 1, the median, quartile 3, and the maximum. Okay, so my minimum in this case is going to be 8. That's pretty straightforward. My maximum is going to be 88. Okay, 25 students means I can count up to 12, and that's my middle. It's 13 to be the middle number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are 26 numbers in this little data point there, but that's okay. We'll pretend there's one less. All right. So maybe we'll ignore one of these 88s or something. Okay. So 64 there is my median, 64. The middle of this group here, if I had 12, is going to be about 6. So 1, 2, 3, 4, 5, 6. So I'm going to chop it up right about there is what I would say it's going to be chopped up as. Okay. So yeah, about 32. Well, if we could go 32, make it a little nicer. Over here, we're going to go 1, 2, 3, 4, 5, 6. And so we would chop it up there at, well, here, 1, 2, 3, 4, 5, 6, 7. So if we did the 7, let's do that. Let's make this 7, 7. So we'll go 32 and 80. Okay, I'm just going to adjust based upon the numbers that I have here, okay? I think it should have been 26. We're going to leave that there. That works for the median. So I'll make the middle number 32, the middle 80. Okay, so I'm just playing with the numbers here a little bit. Sorry, this number should have been changed, I believe, but I don't write the book. Okay, so let's make our box plot. Okay, and we can have 8. We can have, well, same thing, 16, 24, 32, 40, 48, 56, 64, 72, 80, and 88 up to there. All right, so my points I'm going to need, I have a point at 8. We have 16, 24, 32 is here. 64 is going to be 40, 48, 56, 64 is here. And then 80 is going to be here. And then 88. Okay, so that's my box plot, which means I'm going to have my box is going to go around this part there. My median drops in there, and I put in my whiskers, whatever you want to call them, right there. Okay, so that's the craziness that it looks like, something along those lines. So what information about the data is provided by the box plot that is not provided by the dot plot? Kind of, if you look at the two, what information do you get here? Well, one big piece of information that you get from the box is you can actually get the median, which you don't get the other way. That's a piece of information that you don't see with this. You don't see the median because you have to kind of count it out there. Okay, it also shows you the quartiles too if you're interested in what the quartiles are going to be. All right, for the next question, what information about the data is provided by the dot plot that is not provided by the box plot? Well, in terms of this, the dot plot shows all values. And that's sometimes important. You want to see all the values. Here, I can't see all the values in a box plot, but I can definitely see them all in the dot plot. Okay? E, it was recommended that students drink 48 or more ounces of water. How could you use a histogram to easily display the number of students who drank the recommended amount? Well, if the recommended amount is 48 or more, okay, we could look at a histogram if we rewrote this, and we'd be able to take a look at these guys there and quickly see that, oh, that big chunk is all that actually drank the amount of water they're supposed to. So you could make a histogram if you wanted to, where you went from 0 to 48 to 88. And if you did that, you'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, like 12 over here, compared to the other 12 or 15 over there, whatever it might be, maybe a little more, and you can kind of compare it like that. Okay, something you could do. All right, number 5. The box plot represents the distribution of the number of points scored by a cross-country team at 12 meets. So these are their points at a cross-country meet. If possible, find the mean. If not, explain why. Well, to find the mean, what do you have to have? You have to have numbers, right? Remember, you have to add the numbers and then divide by the total things that are there, right? The total events or whatever it might be. Do we have any numbers? Nope, we don't have any actual numbers. So this is something we cannot do. This is something we can't do because we don't have the numbers. Okay, if possible, can I find the median? Well, the median is simply going to be the middle point. And the middle point, it's easy to find on a box and whisker plot because I look for that line and that tells you the median is going to be right there. I can solve for that. All right. Did the cross-country team ever score 30 points at a meet? Now, the thing with the 30 points is this is very exact. That's an exact point. That's the drawback of a box plot and and even a histogram. I can't be exact always. The middle number is exact, right? So the quartile 1 can be exact. That's a number. Quartile 3 is exact. The median's exact. The minimum's exact, and the maximum's exact. But finding 30, I know 30's here. It might have happened, but there's not a point, so I can't answer that question. There's no way for me to actually answer that question, which is what your answer is supposed to be. All right, that's really it for today. Hope that helped you out. So far, we've done 4 of these lessons so far. I'll do my best to keep them coming as much as possible. Again, hopefully this resource was helpful for you. Let your friends know about it, and have a great day, and we'll see you next time.